Welcome back to Thermal Expansion of Liquids on Udimking Education Foundation. Up until now, we have established a universal rule in physics. When you heat things up, they expand. When you cool them down, they contract and shrink. Every ordinary liquid in the world follows this exact rule. But in this lesson, we are going to look at a very special, natural, and wonderful liquid. A liquid that you use every single day. Water. Water is a fascinating rebel. Within a tiny magical temperature window between 0 degrees and 4 degrees centigrade, water looks at the laws of physics and decides to do the exact opposite. Yes, you heard that right. Instead of contracting as it cools down to freezing, water behaves strangely. It starts expanding because this behavior is so unusual, so completely unexpected. The world of science calls it the anomalous expansion of water. Let's see exactly how this beautiful anomaly works. Let's break down the lifetime journey of water as it changes temperature. Imagine we start with very cold water at 0 degrees centigrade and begin to heat it up. From 0 degrees all the way up to 4 degrees centigrade, water behaves in an opposite manner. Rather than expand, it contracts and its volume shrinks, making it tighter and heavier. But the moment it hits exactly 4 degrees centigrade, something incredible happens. 4 degrees is the ultimate turning point. At 4 degrees centigrade, water reaches its absolute smallest possible volume and its maximum possible density. It simply cannot get any more compact or smaller in volume. If you continue heating it above 4 degrees, heading up to 7, 8, 9, and on and on and on, what do we observe? Water suddenly stops shrinking immediately after that 4 degrees centigrade. Rather, it behaves perfectly like any other liquid. Its molecules begin to shift into a wider, open structure. The volume starts climbing upward, making the water expand and become lighter. This strange behavior leads to a major physical reality when water finally freezes at 0 degrees. Because water expands as it turns into solid ice, that ice winds up trapping a lot of empty space inside its crystal structure. This means solid ice has a lower density than the liquid water beneath it. And that is the exact reason why ice floats on water. Have you ever stopped to think about how rare and world-shaping this is? In almost every other substance on Earth, their solid form sinks straight to the bottom of their liquid form. This is because their solid form is tighter than their liquid form, making their solid denser, and thus they sink. Water says, no, I won't do that. My solid will float. That is why we see ice floating in water. Think back to the famous historical story and the movie Titanic. A colossal passenger ship collided with a giant floating iceberg. But consider this mystery. If ice behaved like normal materials, that massive iceberg would have sunk straight to the dark bottom of the ocean floor. The moment it formed, the surface of the sea would have been completely clear, and that tragic collision might never have occurred. While floating ice was a hazard for ships, it is a grand masterpiece of design for nature. Let's travel to a freezing temperate region during the peak of winter. As the cold winter air chills the surface of a pond, the surface water cools down toward 4 degrees centigrade. Because water at 4 degrees is at its absolute heaviest and densest, it sinks straight down to the bottom of the pond, pushing the lighter, warmer water up to be cooled. Eventually, the surface water reaches 0 degrees and freezes into a solid sheet of ice. This floating ice sheet acts like a giant, warm thermal blanket. It traps the heat underneath and prevents the rest of the deep pond from freezing solid. Down at the bottom, a stable, safe layer of heavy water remains at a constant 4 degrees centigrade. Because of this, fish, and other aquatic life don't get trapped in solid ice. They can quietly swim down to the bottom and comfortably survive the harshest winters until situation improves upstairs. You can even see this anomaly inside your own kitchen. If you fill a glass bottle completely to the brim with water, seal it tight, and throw it into the freezer, you will return to find the glass shattered into pieces. As the water cooled past 4 degrees, it expanded with immense structural force, breaking the container. Water truly is a wonderful, uniquely balanced creation that preserves life across our planet through its rebellious nature. Thank you for joining our class today. Don't forget to like this video and follow the Udimking Education Foundation on our WhatsApp channel and social media networks so you are always updated. See you in our next lesson.
Udimking Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.